Imagine, if you would, that you are a chemist in the mid-18th century. You manage to get your hands on a sample of the recently discovered element platinum, and you do what everyone else is doing. You dissolve it in acid. This produces a variety of metal salts that you can study further, but there's a small amount of black dust that doesn't dissolve in the acid. It's frustrating because no one can quite agree on what exactly it is. As it turns out, this seemingly useless powder contains a new metal, specifically osmium. A metal that is difficult to do anything with, but without it, modern agriculture might actually look very different. This is the story of osmium. Hello and welcome to Meet the Elements, the series where I tell the stories of humanity through the lens of the periodic table. It's time to look at osmium, and I'm gonna say it right now, this might be a shorter episode. It's not that osmium isn't interesting, but it has very limited uses, and the uses it does have aren't the most impressive. But let's go ahead and get into it. It's the late 18th century, and chemists are having fun uncovering new elements left and right. One of the larger discoveries that had a massive cultural impact was the discovery of platinum. Platinum was first brought to Europe from South America, where the indigenous peoples had been using the metal for centuries. But platinum was a marvel, seeming like a new noble metal, more valuable than gold. It was beautiful, resistant to corrosion, and had a silvery white shine to it. For the chemists who studied platinum, they would often dissolve it using aqua regia, a mixture of concentrated nitric and hydrochloric acids that is very good at dissolving metals. The platinum would dissolve into a beautiful golden red liquid, ready to be separated from any impurities. But even with the platinum fully dissolved, there was always something left behind. There was always a small amount of a black powder that simply refused to dissolve. No matter what was done to it, the powder stubbornly remained. Many of the chemists at the time dismissed it. The French chemist Joseph Louis Proust believed it was just graphite. So for decades, this black powder was ignored and probably washed down the drains of Europe's laboratories. It was nothing more than trash. But they were all wrong, and in 1803 the British chemist Smithson Tennant figured out what this black powder actually was. See, a few years earlier, Tennant went into business with an old classmate of his, William Hyde Wollaston. The plan was to make boilers out of platinum, and so the two obtained a massive 400-pound chunk of platinum ore from South America. Over the course of dissolving pieces of the platinum ore in acid, the two also examined that black powder. Wollaston went on to discover a couple elements himself, but Tennant also discovered two elements, iridium and osmium. The thing that Tennant did to actually discover osmium was to treat the black powder with sodium hydroxide and then get it red hot. This formed a new yellow-colored solution. As Tennant continued examining this new solution by adding acid to it, he noticed it started to give off a pungent odor, supposedly smelling like chlorine with a slight hint of garlic. Because of this defining odor, Tennant decided to name his new element osmium, after the Greek word osmi meaning to smell, although we now know that the smell comes from osmium tetroxide rather than osmium itself. Now, osmium's discovery is all well and good if you're a new chemist, wahoo, new element! But for most people, they probably care more about what osmium can be used for, and the answer is not all that much. Probably the most relevant application of the metal is in alloys. Osmium is the densest naturally occurring element, about twice as dense as lead, and its toughness makes it very useful in metal alloys that need to be durable. A good example of this application comes into play with fountain pens. The tip of a fountain pen has to withstand constant friction against the paper while being bathed in possibly corrosive ink. Early steel tips wore out too quickly, and gold tips were far too soft. The solution came in the form of an osmium-iridium alloy, often called osmiridium. Osmium alloys are tough and durable, making them ideal for components that need to be wear-resistant. But osmium tends to have more scientific applications, a major one being staining biological samples for electron microscopy. The osmium staining helps improve contrast of the samples and gives a more detailed image. And then osmium has uses in organic synthesis reactions, which I will not be getting into. But there is one rather important chemical process that osmium played a rather important role in, that being the Haber process. If you want a deeper explanation of the Haber process, you can go check out the video I did on Fritz Haber, but I'll give a short summary here. Essentially, as the 19th century was rolling into the 20th, we realized that the agricultural practices at the time wouldn't be able to keep up with the exponential population growth. The main issue had to do with access to nitrates, a key component of fertilizer. Most nitrate production at the time used natural sources, like minerals or guano, but those sources were not enough. We needed a way to produce nitrates, or rather ammonia, at an industrial scale. The German chemist Fritz Haber came up with a way to do so, using the abundant source of nitrogen that is the atmosphere. The main hurdle of taking nitrogen and hydrogen gases and turning them into ammonia was thermodynamics. The chemical reaction would not happen spontaneously at ambient conditions, so you add heat to give the reaction more energy. But even that's not enough, so then you increase the pressure, shifting the direction the chemical equilibrium wants to move. But it's still not quite enough, so you throw a catalyst in there, lowering the amount of energy needed for the reaction to progress. But Haber needed to find the right catalyst to get the reaction to work. In the first decade of the 20th century, Haber tried the rare and expensive osmium as a catalyst, and it worked, producing ammonia from the air drop by drop. The process was purchased by the German chemical company BASF, and was given to the chemist Carl Bosch to scale up to an industrial level. Of course, because of osmium's rarity, it was quickly replaced with a significantly cheaper iron catalyst. Even so, the early success of osmium as a catalyst paved the way for the Haber process to revolutionize the world. The Haber process is still used to this very day, and the ammonia it produces is used to make fertilizers that help the modern agriculture industry produce the very food we all eat. Now, it's likely Haber would have found a suitable catalyst eventually, but I would argue that the early success of osmium as a catalyst is what made the process appealing to BASF, since it was shown to have potential. So osmium started as a somewhat irksome black powder, but ended up proving the Haber process was a viable way to produce ammonia. It went from a scientific curiosity to the key that unlocked a reaction that now helps feed billions. Osmium may not have many uses, and it's unlikely you'll encounter it in your daily life. But osmium's story is a testament to how science tends to work. It shows that progress isn't always about finding what you're looking for, but about paying attention to the anomalies, the things that don't quite fit. Smithson Tennant was simply curious about what the strange black powder that came out of platinum was. He saw a mystery where others saw waste. Sometimes the most profound secrets are just waiting for someone to look a little closer. Thanks for watching. So, like I said, osmium just doesn't have that much to talk about. It's used in alloys for very specific things, and it gave an early success to the Haber process. That's about it. But let me know, what do you think about osmium? What part of its story do you find the most interesting? Leave your answer down in the comments. And don't forget to leave a suggestion for the next element you want to see me cover. And if you want more stories about the elements that influence our lives, make sure to subscribe so you don't miss the next episode of Meet the Elements.